So today we will be talking about section 5.4, linear approximation. We are starting on slide number 18. So let's go ahead and read slide number 18. It says, using a tangent line to f of x at x equals c to approximate values of f of x for x values close to c. So if we draw a picture, and let's say we have a particular value here at x equals c, the y value, of course, would be f of c. So we are going to be using a tangent line. So let's go ahead and draw in the tangent line. And so we can use the tangent line to approximate values of the function near x equals c. For instance, let's say we had this value over here, and we wanted to approximate it. We could use the point on the tangent line to approximate the value of this point because they are close to each other. However, this curve happens to be concave down. And so if f of x is concave down here, then our estimate would be an overestimate because that point is greater than the point on the actual curve. On the flip side, if we have a curve that is concave up, then the tangent line would be an underestimate. So for instance, the tangent line is here. If we were trying to estimate a point on the curve, our estimate on the tangent line here would be an underestimate because it is below the point. So what we're going to be doing is we are going to be taking a derivative, writing a tangent line, and using the tangent line to estimate the value of the function. So we'll do this in our first example. So on to slide 19. It says find the approximate value of y equals root x at x equals 9.2 from the tangent to the graph at x equals 9. So in this case, 9 is like our c value. And what we are going to do is we are going to use the point at 9 to help us approximate the point at 9.2. All right, so how do we do this? Well, the first step is to write the equation of the tangent line at c. So write the equation of the tangent line at x equals c. All right, so that's pretty easy. How do we write the equation of a tangent line? I need a point and a slope. So my point is going to be 9 comma, well, square root of 9, right? So 9 comma 3, that's my point. So write yourself a note here, point. And then we need a slope. All right, so how do I find the slope? Obviously, y is root x, so y prime is 1/2 x to the negative 1/2, right? Which means that y prime evaluated at x equals 9 is going to be 1/2 9 to the negative 1/2. Now, what does 9 to the negative 1/2 mean? Well, 1/2 times 1 over the square root of 9. So the square root of 9 is, of course, 3. So 1/2 times 1/3 is 1/6. So that is the slope of the tangent line. So make sure you write yourself that note. And so our equation of the tangent line is going to be y minus 3 equals slope of 1/6 times x minus 9. All right, so now what does that help us to do? All right, so let's draw a picture. If I draw the graph of the square root of x, it looks like that. Now, there's a point here that we're dealing with, 9 comma 3. Now, what we are wishing to do is approximate the value of the square root of x at x equals 9.2. So we are trying to approximate the y value at this point. So that point would be 9.2 comma question mark, whatever that's our answer. So we're going to use the tangent line. So we draw in the tangent line, and we just wrote that equation. All right, so what we're going to do is we are going to figure out the point 9.2 comma the y value on the tangent line. And that y value is going to be our estimate. All right, so how do we do that? So step 2 is to plug x equals 9.2 into the tangent line. So that's actually pretty easy. Y minus 3 equals 1/6 times 9.2 minus 9. All right, so obviously 9.2 minus 9 is just 0.2, and 0.2 is 1/5. So y minus 3 equals 1/6 times 1/5. So 1/6 times 1/5 is 1/30th. So y equals, if I add 3 plus 1/30th. Now, just to verify our result, we should figure out that 1/30th is 0.03 repeating. So this is actually 3.03 repeating. So now, why is it useful to get that decimal? Well, because we were using this to estimate the value of the square root of 9.2. So what is the square root of 9.2? If we calculate that, we get the square root of 9.2, which is 3.03315, and so on. So now, is 3.03 repeating a pretty good estimate of the square root of 9.2? Yes, it's actually very good. Now, is this an overestimate or an underestimate? If we look at our picture, the 3.03 repeating is a point above the point on the curve. So that would be an overestimate. So is 3.03 repeating more than 3.033150? Yes, obviously it is. So our estimate from the tangent line is 3.03 repeating. So now, another problem, very similar. Slide number 20. Same idea, but a little bit different. All right, so it says, if f of x is the square root of 4 plus 2 sine x, find the linear approximation of f of 0.1. All right, so now this time I don't tell you the value of c, but think about it. We are looking for 0.1. What is a really easy number to use that is close to 0.1? Obviously, that would be 0. So in this case, we're going to use c equal to 0. So first step is to write the equation of the tangent line. So step 1, we need a point, and we need a slope. All right, so the point would be 0, comma. All right, so now I'm plugging in f of 0. So what is f of 0? The square root of 4 plus 2 times the sine of 0. What is the sine of 0? It's 0. 2 times 0 is 0. 4 plus 0 is 4. Square root of 4 is 2. So our point is 0, 2. Next, the slope. All right, so we have f of x, so we need f prime of x. All right, so the square root of 4 plus 2 sine x. So we would have 1/2 4 plus 2 sine x to the negative 1/2 times the derivative of 4 plus 2 sine x. So what's the derivative of 4? 0. Plus the derivative of 2 sine x. So 2 times the derivative of sine, which is cosine x. Okay, that's our derivative. So now the specific slope of the tangent would be f prime of 0. All right, so 1/2 times 4 plus 2 sine of 0 to the negative 1/2 times 2 cosine of 0. All right, so now 1/2 4 plus 2 times sine of 0. So 4 plus 2 times sine of 0. Sine of 0 is 0 times 2 is 0. 4 plus that is 4. So I have 1/2 times 4 to the negative 1/2, which means 1 over the square root of 4, times 2 cosine of 0. What's the cosine of 0? That's 1. So I actually have 1/2 and 2 reduced. So the square root of 4 is 2. So my slope of the tangent is 1/2. So equation of the tangent line. Y minus 2 equals 1/2 x minus 0. So now step 2 is to plug the value that we're trying to estimate in to our tangent line. So y minus 2 equals 1/2 0.1. All right, so y minus 2 equals half of 0.1. Well, what is 0.1? Well, 0.1 is 1/10, so half of 1/10 would be 1/20. And so if I add 2, I get y equals 2 plus 1/20. Now, of course, 1/20 is 0.05. So this would be 2.05. That is our estimate of f of 0.1. Now, just to verify this, we're going to calculate the square root of 4 plus 2 times the sine of 0.1. All right, so if you're going to calculate, make sure your calculator is in radians. So we take the square root of 4 plus 2 times the sine of 0.1, and we end up with 2.0493. So is 2.05 a pretty good estimate of 2.0493? Yes, obviously it is. Now, our estimate, 2.05, is slightly bigger than 2.0493. So what must that mean? That must mean that f is concave down at 0.1. So both of those are nice examples that we can verify, that we could actually use our calculator and check to see how close our estimate is. Those are really not very AP-like, okay? The AP-like question is like our last example, all right? So let's read this. It says, let f be a differentiable function such that f of 3 is 4 and f prime of 3 is 2. Use a tangent line to approximate the value of f of 3.1. So what we need to notice here is that f is not given explicitly. We don't know what f of x actually is. So we could not actually find its true value, which is different than the last two problems. We were able to find the true value of f of 9.2 and f of 0.1. So this is the more AP-like question. So how do we do it? Well, it's actually pretty easy. We take the point, remember f of 3 equals 4, so that means we have a point at 3, 4. And we take the slope of the tangent, which we were told f prime of 3 is 2, so m tan is 2. So we write the equation of the tangent line. Y minus 4 equals slope of 2 times x minus 3. That was really easy, and actually that part is going to be much easier. All right, so now in step 2, we take 3.1 and we plug it in to the tangent line. And so we get y minus 4 equals 2 times 3.1 minus 3. All right, so obviously 3.1 minus 3 is 0.1. So I have 2 times 0.1. So y minus 4 equals 2 times 0.1. What is 2 times 0.1? That's 0.2. So 4 plus 0.2, or 4.2, is our estimate of f of 3.1. So we write f of 3.1 is approximately 4.2. Now, we cannot find the actual value. This is the best that we can do. And so this would be the AP-like question. So that completes our notes for section 5.4. Some of the questions on the homework are going to be very similar to these examples. Others are going to be a little bit of an extension. So your homework tonight is problems 1 through 6 from 5.4.